the SAT practice. As always, I recommend pausing the video when the problem comes up, attempt the problem, and then you can watch the solution or solutions to this. So give this problem a shot. Okay, so in this problem, we have a table that is dealing with dreams recalled during 1 week. We have 2 groups. We have no dreams recalled, 1 to 4 recalled, 5 or more recalled. So let's see what they're asking for. The data in the table above were produced by a sleep researcher studying the number of dreams people recall when asked to record their dreams for 1 week. Group X consisted of 100 people who observed early bedtimes. Group Y consisted of 100 people who observed later bedtimes. Okay, so that's probably important. So X is early, Y is later. If a person is chosen at random from those who recall at least one dream, what is the probability that that person belonged to group Y? So at least one dream is 1 to 4, and it also includes 5 or more. So it could be this group or that group. So we're dealing with these 39 people and these 125 people. So recalled at least one dream would be 39 plus 125. Either do that in your head or you have a calculator for this section. So 39 plus 125, and I get 164. Okay, now I want to know which ones of those belong to group Y. So I'm really only looking at these 2 columns. And group Y are these numbers. So 11 people were from group Y that chose 1 to 4, 68 people were from group Y that chose 5 or more, so that is going to be 11 plus 68. And again, either do that in your head or go to the calculator. I know that's going to be 79. And so this is the number of successful people, the ones in group Y. Given that we know that we're only looking at the people that have at least one dream, so chosen from the people who recalled one dream, so my answer should be 79 over 164. Now you could do this a little bit differently. Instead of adding up, which might have been a little bit trickier, I could have seen that 36 people weren't in my group, so I would do 200 minus 36, get the 164, maybe a little easier. And I could see that either 21 of the total people weren't in there. So I could do subtraction instead of addition, but basically it boils down to this same thing to get the numerator and the denominator. All right, give this problem a shot. Okay, so in this problem we have this table. I apologize that it is so small. I had to make it small to have it all fit on the screen at the same time. And we want to know which of the following best approximates the average rate of change in the annual interest or annual budget for agriculture and natural resources in Kansas from 2008 to 2010. So we want to deal with agriculture and natural resources. We're dealing with this, and we want to know which best approximates the average rate of change from 2008 to 2010. So the best way to do this, I want average rate of change. This is average slope. And the best way to deal with this is to just do slope formula. So my average slope will be sort of my y2 minus y1 over x2 minus x1. I just take my appropriate pair. So I have this right here will be my y1. This right here will be my y2. This right here will be my x1. This right here will be my x2 because I'm doing a rate of change per year. And so I'm just going to calculate 488,106 divided by, minus 358,708 divided by 2010 minus 2008. And I'll do this subtraction in the calculator just to make sure I don't mess it up. So 488,106 minus 358,708. And I get 129,398, so 129,398. And down here, 2010 minus 2008 is just 2. So I'll go and divide that number by 2. It says, let's see, which best approximates. So I get 64,699. And clearly, so it looks like this is going to be my answer now. I didn't notice this at first, but let me look at this carefully. So this is in millions per year. The table above is in thousands. So this is about 65,000, and then I have this here, 1,000. So that's how I got to the million. That's always important to check to make sure what you have. So my answer should be $65 million per year. Now, I'm not going to go through the process, but you can actually find the slope, the average rate of change from here to here, and the average rate of change from here to here, and then do the average of those two numbers. It'll take longer, but you will get the same answer in the end. Okay, give this problem a shot. All right, so we have the same chart from the previous problem. In this one, they want to say, of the following, which program's ratio of its 2007 budget to its 2010 budget is closest to the human resources program ratio of its 2007 to its 2010 budget? So basically, I want to compare a bunch of ratios from 2007 to 2010. Now, I can actually divide them either way as long as I keep it the same, but all I need to do is just look at this sort of piece by piece. So I want to compare it to human resources. So I'm going to take, and I'll do the ending divided by the beginning to show sort of the percentage increase, but you could flip that around and get the percentage that this is less than that. So there's many ways. So I'm going to type this divided by this, see what fraction or see what decimal I get out of there. So let me do that. So we will have 5,921,379. So 5,321,379. Divide. Ooh, that's not right. Let me actually do that correctly. 5,921,379. That's much better. Okay, divided by, that's why you always want to check what you put in the calculator. 4,051,050. Okay, let's see what we get there. So I get about 1.46. And now I just need to see which one of these. Let me mark off which one I want. This one, education, highway transportation, or public safety. Which one of these has a very similar, has the closest fraction? So I'll go through and check those. So I'll do this divided by this. So 488,106 divided by 373,904. 488,106 divided by 373,904, and I get 1.31. So that's probably not my answer, but I'll write it down just in case. I'll only switch colors. That's not so. All right, let's keep going. So I'll try to divide 3 million by 2 million. So 3,008,036. Whoops, 3,008,036. I guess that really wouldn't have mattered in numbers this large, but better safe than sorry. 2,164,607. And I get 1.39. Okay, so closer. Let's keep going. So I have 1,773,893 divided by 1,468,482, and I get 1.21. Okay, one more to check. So 464, and this one already looks way too big, but let's check. 464,233 divided by 263,463, and I get 1.76. And now of all of these, the one that's closest to 1.46 is for education. Now, I could have done one other thing. I could have multiplied these numbers, specifically this, and this, by the 1.46 and seen how close I got sort of as a ratio, but that's a little bit tricky. This is probably the best way to do it. Give this problem a shot. Alright, so we want to know which of the following is an equation of a circle in the xy plane with center 0, 4 and radius with endpoints 4/3, or with endpoint 4/3, 5. So a couple of things here. First off, I need to recall that the equation of a circle is x minus h squared plus y minus k squared equals r squared. And with that, so my center will be at the point hk, in this case 0, 4, and my radius will be r. So let's see if we can eliminate something. So if h is 0, k is 4, I should have an x minus 0 squared plus y minus 4 squared, changing the signs. X minus 0 squared is the same thing as x squared. Alright, let's see what we've got. So right off the bat, I see this minus 4. I see these two with plus 4s, so those are not correct. Now I need to figure out the radius, because beyond the radius, or the r squared here, there is no difference. Now I have a guess, but let me look at it. So in here, to find the radius, well, the radius is just going to be the distance from the center to the circle. My center is here. A point on the circle is there, so I just do distance formula, which means I will do y2, so distance equals square root of y2 minus y1 squared plus x2 minus x1 squared. y2 is 5, y1 is 4, 5 minus 4 is 1. x2 is 4/3, x1 is 0, so I'll have plus 4/3 squared. Now, I'm going to do something that's going to be useful for this problem, but maybe not in every case. So I notice that my equation needs r squared. So this d is just r. So I'm just going to square both sides to get the r squared. And when I do that, notice I don't need to worry about a square root anymore. So I just need to figure out what 1 squared plus 4/3 squared is. 1 squared, 1 times 1 is 1. 4/3 squared is 4 squared, 16, over 3 squared, 9. And then doing a little bit of fractional work, 1 is the same thing as 9/9. So I have 9/9 plus 16/9, and I get 25/9 as my r squared. That means A is my answer. This right here, this 5/3, that's actually r, but my formula has r squared in it. Alright, give this a shot. So here's our last problem for this video. It says the equation above expresses the approximate length or height, h, in meters of a ball t seconds after it is launched vertically upward from the ground with an initial velocity of 25 meters per second. After the approximately how many seconds will the ball hit the ground? So what we have here, we have two variables. We have height h and time t. And so all I need to do is take this equation and do some work on it. Now there are a couple of options. So probably the simplest way, I can't do it nicely with the calculator I have right here, but the simplest way to get a quick answer is I can just go to my calculator and graph y equals negative 4.9 x squared plus 25x, realizing that now this is my height and these are my times because I've changed variables. And when I graph that, I'll see something that looks like this. And just keep in mind what it means to hit the ground. Hit the ground means that the height is 0. And so I can either just think of this like a ball actually going through its path, or realize that, okay, the y value is the height. So it's on the ground here, it starts on the ground, like you might be kicking the ball, or it might be a golf ball that you're hitting from the ground. It says launch from the ground. And then over here, it hits the ground again. So I could basically just figure out, using my calculator with its tools, what this x value is here, and that'll be my answer. But I'm going to do it another way. Same reason, keep in mind that hitting the ground means the height is 0. So I'm going to take this equation and make the height equal to 0. And now I just need to solve this, which is actually not too bad. This is a quadratic equation, but since it does not have a c term, the c term is 0, the constant is 0, I can just factor out the t. So I'll get 0 equals whatever this t is, times negative 4.9 t squared plus 25t. And then using zero product property, since I have this times that equals 0, whenever I multiply two things and get 0, either this has to be 0, so t equals 0, or that has to be 0. Ooh, hold on, that should just be negative 4.9t. That should not have a t there. Sorry about that. I factored out the t. So, or negative 4.9t plus 25 equals 0. And I just solve this by subtracting 25 from both sides. Get negative 4.9t equals negative 25. And now I'll go to the calculator and divide both sides by negative 4.9. So I have negative 25 divided by negative 4.9. You think it's going to work out? Nope, that didn't work out at all. So let me just deal with the, oh, that's probably nice. So 25 negative, there, that's what I want to do, divided by 4.9, which is negative, and then I get about 5.10, and so the closest time is going to be this 5. I can ignore this case, so I can ignore this case here because that is where we started, not where it hits the ground. Okay, I hope that helped out. We'll continue with this test tomorrow.